Hello again everyone, welcome back to ptet.chemistry channel. This is the start of this section B kind of question for classification topic 10.3. That is just polymerization in my classification for no reason whatsoever. Okay, so in this last 10, in this type of last 10 questions for the Cambridge International A-Level syllabus, it's these kind of three statements in which you have to think about a combination of 1, 2, and 3 being relevant to what they are asking. There will be option A, 1 and 2 relevant to whatever they're asking. That's option B. 2 and 3 for option C, and option D is only 1 is relevant to whatever they're asking. This kind of question have been getting more and more popular in the other examination board in recent years, partly because they assess they can assess the students on a variety of concepts rather than just one particular concept. Yeah, but there's a bit of logic around it. We always go for option 2 first, because if option 2 is wrong, then you are left with one option, and so on and so on. Okay, but ideally we should be thinking about really strong content knowledge in order to ask multiple choice questions. Yeah, it can be very easy to score, but it can also be very difficult to score like 38 out of 40 or 39 out of 40 or even full marks. Okay, but it's not impossible. All right, and that's what I'm here for. So what properties of polyalkenes and of PVC? PVC stands for polyvinyl chloride. So you should know your polymer very well. So that is the PVC repeat unit. So I've just shown them being open like that, and that's the polymer unit with a CH2 and a CHCl. So your polymer for polyvinyl chloride is actually chloroethene. Okay, so vinyl chloride refers to chloroethene. Polyvinyl chloride, PVC, is just polychloroethene. So polyalkenes in general, so they're just saying polyalkenes in general are non-biodegradable, and that is correct. Okay, because we are thinking about strong carbon-carbon bond. CH bond is strong and CH bond is non-polar. Okay, and of course when you have PVC like this, when you burn PVC, you can also release off harmful combustion product, because you can imagine this bond being broken and you could form HCl, which can be corrosive gas, and other polyalkenes. Well, I guess polyalkenes, not the other thing I'm thinking of. But anyway, so this thing can definitely give you HCl amongst many other harmful combustion products. Yeah, so example HCl, the Cl coming from the cleavage or the rupture of the carbon-chlorine bond. Okay, so that is true. Now, polyalkenes are highly flammable. This is a property you might not be very familiar with, but if you think about your plastic bag, if you put fire onto it, do you think your plastic bag burn easily? They are not highly flammable. Okay, so they do not burn that easily at all. All right, so only 2 and 3 are correct. So it's option C. This next bit looks complicated, but anyway, so when you have a monomer undergoes addition polymerization, you started with 1 mole of the sample. Okay, so how many moles of polymer theoretically be formed? All right, so we know that monomer becoming addition polymer. So what is so special about addition polymer, you have learned it even in O-level and GCSE, is that, you know, there is no other byproduct. You do not kick out any other small molecule, because this is not condensation polymerization. This is addition polymerization. We talk about same empirical formula, because you are not kicking out any byproduct at all. So the polymer itself has the same empirical formula, which is the simplest ratio of atoms, okay, in that molecule or in that compound, as the monomer, because you're not forming anything else. You see, you have n number of the monomers, and you have the chain has n number of repeat chain. Yeah, you started with 1 mole of the monomer. So I guess what can we be saying here? I guess you could see the stoichiometry is going to be n times of monomer, give you 1 time of the polymer with n number of chains, right? Repeated chain essentially. So if I make this into 1, that is n over n, then I'll get 1 over n addition polymer, I guess. Okay, so now if that is equal to 1 mole, okay, which means n is going to be greater than 1 because we started with more than 1 monomer to give you that. So if n is greater than 1, n has to be greater than 1 again because you need to have more than 1 monomer to give you a polymer, right, where you add together. So if n is greater than 1, 1 over something greater than 1 must be lesser than 1. Okay, so therefore, I mean by logic, therefore 1 over n is lesser than 1. It cannot be 1 because, you know, you need to have more than 1 monomer to give you addition polymer. 1 over that is lesser than 1. 10 to the minus 6 is lesser than 1. So both of them are theoretically possible, whereas 1 is theoretically impossible when n is required to be greater than 1 for you to have monomers added together to give you addition polymer. Okay, so a bit of logical thinking there, I guess. In this next question, it just looks complicated. So what do we know? I think with this question, it's best if you start by drawing out the what I mean is drawing is like numbering. Okay, if you number them, if it's 1 2 3 4 5 6, so what happened is you could have 7 8 9 10 11 12. So this could add on to that, and that could add on to something else, whereas something add on to this one. So they keep on adding, yeah, alright? So what we could have is, if this is 6, if this is 1, something is added towards there. 6 is added to 7, and then 8 is added to something else. Okay, so it goes like that. So if we check at number 2, does that seems alright? So that is 1 2 3 4 5, and then 7 8 9 10 11 12. I think I want you to see 1 and 6. Okay, so 6 and 7 are joined together. If that is 6, that is 5 4 3 2 1. Okay, 1 is bonded to something else, 1 is bonded to something else, and then 7 8 9 10 11 12. 8 is bonded to something else, 8 is bonded to something else, and again it continues and continues. And as long as you could see that there's another one next to that connects it. Okay, so they are joined together, separated by one carbon only. Number 2 is definitely correct. Okay, so number 2 is legit correct. Okay, how about number 1? So if I check number 1, could you get number 1? How can you get number 1? If I have that, if I have this, and if I have that, so if that is added to that, that is added to that, that is added to that, then that thing becomes that single bond there. So this thing will give you the green bond there, and red will be this thing there, will give you there, and I guess this brown thing will give you a single bond there, and you will lose all the double bond characters. So 1 is indeed possible as well. Okay, addition reaction with cyclohexene as the only reagent. Okay, as the only reagent or as the only reactant. So 1 and 2 are fine. How about number 3? Hope you can see, if you have that, it is impossible because you have a double bond there. So where you join them, one must be added, the other one must be added to something, alright? What do you have here? You do not have anything, you see? This is your join, okay? But there is nothing there. Nothing. One carbon away from the, I guess from the extent extension point. What do I mean by extension point? I guess this is the point where you extend. It gets added on one side. That means on the next carbon, whether here or here, it should be added to something. But here you see totally empty. That's how I know option 3 is definitely wrong. Okay, so 1 and 2 would give me B. Again, this hard question requires a lot of logical thinking, yeah? And it wouldn't help if you just choose your option without drawing, without trying to numbering it, without trying to imagine what actually happens. Okay? In this next question, we have a couple of these statements. We're looking at something that contains a halogenyl alkane. So a halogenyl alkane has a halogen directly bonded to an alkane. And this is the textile for use in an aircraft. So I haven't flown in an aeroplane for a long time, but if you have flown in one, you will have sat on one of those really nice, comfortable seats. They are made of these particular textiles. So why do we use halogenyl alkanes? Well, you got to think about the uses of halogenyl alkane. So we know about their use in Teflon, for example. So Teflon is used for making cooking pans. Because they are inert, they don't react because of the strong carbon-fluorine bond. They are used as a flame retardant. Well, they are not used as flame retardant. They are used for making flame retardant materials, like the materials for fire brigades, those people who protect or save against fire. Yeah. So what's the reason for this? Well, you purposely made it with for the purpose of textiles. So we're looking really at flame retardant purposes there. So it burns less easily, therefore improving safety. Those material for the clothing for fire brigade officers, the people who actually had to brave through fires, they continuously burnt. They don't burn easily. The halogenyl alkane materials don't burn easily. That's why it will protect them, giving them an extra level of safety. So 1 is definitely correct. In terms of number 2, the fabric forms hydrogen bond to water. Now this is a bit tricky, and this was the bit where I actually made a mistake previously, and someone had to correct me, and hence I'm re-uploading this video as part of correction so that more people don't get confused. So thank you to the other person who actually corrected me. When you think about halogenyl alkane, we could be looking at a simple halogenyl alkane like, I don't know, bromine like this. Or we could be looking at a fluorine, for instance, or chlorine. So let's say I have a fluorine like that. Doesn't matter. Halogenyl alkane, halogen bonded to a part of an alkane chain. So what happened there is, even though we have this highly electronegative fluorine, but it is not bonded to hydrogen. So the fluorine is not bonded to hydrogen. In fact, I have drawn alkanes, whereas I should be drawing alkene, because when they polymerize, they will give you the polymer. They will give you the polymer as such. It will be looking like this instead. So they won't give you an alkane product. They'll give you a polymeric chain. They'll give you an addition polymer. But importantly, whether you are in the monomer or the addition polymer, the fluorine is not bonded to the hydrogen. If the fluorine or the oxygen or the nitrogen, they are not bonded to the hydrogen, you cannot have hydrogen bond, because the most important concept of hydrogen bond is you must have a hydrogen atom bonded to a highly electronegative atoms such as fluorine, nitrogen, or oxygen. In this halogenyl alkane, the fluorine is not bonded to any hydrogen at all. So this one technically is wrong. Well, actually, it's not just technically, it is definitely wrong. And this was my mistake previously. So don't make the same mistake as me. So make sure you can read the question and understand the concept of hydrogen bond. 2 is definitely wrong, so this leaves option number 1 as the only possible answer. As you know from the 4 options, if 2 is wrong, only number 1 can be correct there. Okay? This is the last question of this 5-question series. So this is about Kevlar. Kevlar is actually used in what is that thing I was gonna say? Bulletproof vest. All right. So military as well as the police forces, they would use these to prevent attack against bullet because it can absorb the force. So you don't get the bullet impact on your body, but you still get the force and you don't get the bullet passing through the body, but you still feel the force onto the body. Yeah. This Kevlar stops the fast moving bullet, so that's why it's gonna hurt your body a lot. All right, if you ever go into the police force or the army, then you would experience this at some point. Okay, it's not rest, yeah, it's vest, VEST. Okay, so what properties of Kevlar help to explain that it's lighter and stronger? Okay, I hope you can see and relate it to your O-level. You have a lot of these things. These things are called amide. Okay, so you learn it as amide linkage. We learn it as amide functional group, C double bond or NH. And the thing is, this is a nitrogen with lone pair. This is a delta plus and delta minus. Oops, that is wrong. Delta minus, there's delta minus, delta plus. So they can form H bond, which is hydrogen bond, between the different chain. So imagine you have another chain or a couple more chains along, and you can have hydrogen bond between the polar group, between the CO and H group, with another CO and H group on another chain. All right. So they do align due to hydrogen bonding, okay, because that is the driving force for them aligning. Now that is for stronger, okay, so that explains why it's stronger. But how does it explain it's lighter? Okay, so we're saying that steel versus Kevlar, so you want to put it onto your body, so you want it to be light. If you compare to a steel rope, all right, which is strong but it's not light at all. Okay, so the mass per unit length is less in the Kevlar. So it's saying that if you have the same length, okay, so the mass per length, since Kevlar is lighter, okay, because Kevlar is lighter, so for the same length, Kevlar is lighter, so L is the same, L is constant, so M of Kevlar must be lesser than M of steel, because for the same length, Kevlar is lighter. That's the information. The mass per unit length is less in the Kevlar than in a steel. 2 is correct as well. The Kevlar molecule has no permanent dipole is incorrect. I just shown you that. If 1 is correct, 3 is incorrect, because the fact that you can form hydrogen bond means that you have very polar dipoles, or very polar bonds, okay, as a result of these permanent dipoles. Alright, so 3 is wrong, only 1 and 2 are correct. So this is the end of this 5-question series on polymerization kind of question. A few questions were really difficult to understand unless you start drawing and getting your hands dirty and trying it out, yeah, rather than just watching me doing it. Okay, so I'll see you in the next video. If you have found these tutorials helpful, don't forget to subscribe and share the channel widely with friends, class group chat, and juniors, seniors in school, anyone else who will find the chemistry contents on my channel useful. All right, thank you for watching again.